Hello student. So last time we discussed about major losses. So this time we will discuss about minor losses. So here you can see these are some of the minor losses. So loss due to sudden enlargement. If diameter of pipeline suddenly increase, so at that time also loss occur. So that will be known as minor losses. So sudden enlargement, sudden contraction, and at the entry, at the exit of pipe, if there is a obstruction in pipe. So because of this reason, if losses occur, so that will be known as minor losses. So we will not discuss all in detail, but first losses we will have to discuss in detail, because here we will have to derive equation for loss. So let us draw diagram and then after we will derive that equation. So here let us assume here we have pipeline. So in pipeline, if there is sudden enlargement, so suppose let us tell at this section as a 1, and here let us tell this section as a 2, and flow is taking place in this direction. Clear? So let us apply Bernoulli equation first. Here let us apply Bernoulli's equation. So if you will apply Bernoulli equation, P1 by rho g plus V1 square by 2g plus Z1 is equal to P2 by rho g plus V2 square by 2g plus Z2 plus HE. Now here you can see these we can cancel because there is no height difference, so that we can cancel. So what will be the equation of HE? Equation of HE, here you can see P1 minus P2 divided by rho g plus V1 square minus V2 square divided by 2g. So let us tell it as a equation A. So we will use it later on. Now according to force we will derive one equation. So here suppose here area is changing, so velocity also we will have to consider, but whenever we will only consider pressure at that time. Here you can see, suppose this is pipeline, it has a area A2, clear, and suppose these are the point 1 and 2. So at that time what will be the equation of force? P1 minus P2 into A2. This will be the equation. Let us tell it as a equation B. So now we will have to consider momentum equation. Momentum. So now in momentum equation, let us tell it as a momentum at point 1. Momentum at point 1. So what will be the momentum? Momentum means mass into velocity. So what is mass? We know that density is equal to, what is density? Mass divided by volume. Mass divided by volume. Now what is volume? That we know. Area into velocity. That is our volume. So what will be the mass? Mass is equal to rho into A1 V1 into V1. So final equation will be rho A1 V1 square. So this is momentum at point 1. Now momentum at point 2, m into V2. So again same way, here we will have to write A2 V2 and here V2. So what will be the equation? Rho A2 V2 square. Clear? Now we know that change in momentum is equal to force. So now equation of force we will have to take from equation B. From equation B we will have to take equation of force, and here also we will write down change in momentum means rho A2 V2 square minus rho A1 V1 square. Clear? Now here we want to replace this A1. I want to replace this A1. So which equation we have? We know that A1 V1 is equal to A2 V2. So what will be the A1? In place of A1, what we can write down? A2 V2 divided by V1. So let us replace that. Rho A2 V2 square, and here what you will have to write? Rho A2 V2. Here you have V1 square, and at the back you will have bottom you will have V1. So V1 get cancelled. So what will be the final formula? Final formula will be, suppose you can keep this as a common, rho A2, and in bracket what you will have? V2 square minus V1 into V2. V1 into V2. So this will be the equation. Now from here basically we will find out P1 minus P2. So here this is the equation for this. So what will be the P1 minus P2? So A2 get cancelled. So P1 minus P2 will be rho V2 square minus V1 V2. Now then after, here what will be the P1 minus P2 divided by rho is equal to V2 square minus V1 by V2. Now here let us divide both the side with G. Clear? So P1 minus P2 divided by rho G is equal to V2 square minus V1 V2 divided by G. So this is our equation for P1 minus P2 divided by rho G. Now this equation, this value we will put in equation A. So what was our equation A? Let us check that. HE is equal to, let us write down that again. H is equal to P1 minus P2 divided by rho G plus V1 square minus V2 square divided by 2G. So here let us write down this. So in place of P1 minus P2 by rho G, what we will have to write? V2 square minus V1 V2 divided by G plus V1 square minus V2 square divided by 2G. Now here suppose here you are multiplying 2, so here on upper side also you will have to multiply by 2. So what will be the final answer? 2 V2 square minus 2 V1 V2 plus V1 square minus V2 square divided by 2G. So once again, V1 square minus 2 V1 V2 plus V2 square divided by 2G. So this is the equation of V1 minus V2 whole square. This is basically equation of V1 minus V2 whole square divided by 2G. So here you can see that is our HE. So this is head loss because of or due to sudden expansion. Now rest of the loss here you can directly check. No need to go in detail. So if there is a sudden contraction, then this is the equation for head loss. What is the equation? 0.5 V2 square by 2G. This is the equation if there is a sudden contraction. Then after, now loss of head at the entrance of the pipe. So this is equation. If at the entrance of pipeline, this is the equation. Exit of the pipeline, this is the equation. If obstruction is there inside pipeline, This is the equation of head loss. Loss of head due to bend in pipe, if there is a bend in pipeline, this is the equation. Or loss because of pipe fitting, so these are the equation. Now this equation you will have to remember, so no need to derive those equation. So thank you all for listening me. I hope that you understood this theory is understood by you very well. Thank you.